Hello and welcome to a new video on IGCSE Mathematics. In this video, we shall be discussing transformations, and more specifically, we shall be discussing rotations. We shall begin with drawing or graphing rotations with a center origin. So in this question, we are required to draw the image of triangle T after a rotation through 90-degree clockwise about 0, 0. So let's first talk about the types of different rotations. So let's take a random point. This point has coordinates A and B. If we want to rotate this point, for example, 90 degrees clockwise, what happens is that this point here moves a quarter of a circle. So if we want to draw the full circle just to understand what's going on, we can draw a line like this. And then the circle would be something like this. So 90-degree clockwise would be a quarter of a circle. Again, you can also draw another line like this to understand what I mean by a quarter circle. So this part here would be 90 degrees clockwise. And the point that we reach here has the opposite coordinates. So it has B and A. And of course, you can tell here that the X value is positive because this is the X-axis. So the X is positive and the Y is negative. So it actually has B negative A. So therefore, 90-degree clockwise, AB becomes B negative A. Now, for the 90-degree anti-clockwise, the point moves in the opposite direction, of course. So it moves along this yellow arc or quarter circle, and it reaches this point again. So we can apply the same logic. We're just going to change the coordinates of the point. So again, it becomes BA, but this time the X is negative and the Y is positive. So therefore, 90 degrees anti-clockwise turns AB into negative B and A. So AB becomes negative B and positive A. Finally, we have a 180-degree rotation, whether clockwise or anti-clockwise. In both cases, the point will end up moving half a circle. So it will end up reaching this point here. And the coordinates of this point would just be negative A, negative B without switching A and B like we did in the 90 degrees. You can think of this as two 90-degree rotations. So from A to B here, I mean, A comma B here becomes B comma A, and then B comma A becomes A comma B again. And in terms of negatives and positives, you can just think of it in terms of quadrants. So this is quadrant 1, where X and Y are positive. This is quadrant 2, where X is negative, but Y is positive. This is quadrant 3, where both are negative. And this is quadrant 4, where only the Y is negative, but the X is positive. So for a 180-degree rotation, whether clockwise or anti-clockwise, AB becomes negative A and negative B. This is a summary of what happens when we rotate either 90 or 180. Not that 270 comes a lot, but you can think of 270 just in case. So 270 clockwise is the same as 90 anti-clockwise, and 270 anti-clockwise would be the same as 90 clockwise. And we can see this on the circle. So for example, if we take point AB and we move 270 clockwise, so we would move in this direction. This is 90, this is 180, and then this is 270. So we're back at this point here, which is the same as what we got when we moved 90 anti-clockwise. So 270 clockwise is the same as moving 90 anti-clockwise. So the purpose of this part of the explanation was just to tell you what happens with the different rotations. Next, we're going to establish a technique with which we can find the rotation of any shape quite easily. So this technique involves drawing a small table. We have P and then OP and then OP dash and then P dash. So P is a vector with given coordinates. So for example, it has XY or AB or whatever. And then OP is also a vector, which is simply P minus O. So to go to OP, all we have to do is just P minus O, and I'm going to specify what O is right now. And then we have OP dash. So to go from OP to OP dash, we apply the type of transformation or the type of rotation that they gave us in the question. So for example, in this question here, we have 90 clockwise, and we said that for 90 clockwise, AB becomes BA, and it's in quadrant 4, so the X is positive and the Y is negative, so it becomes B negative A. So for this case here, AB becomes B negative A. And then finally, to go to P dash, we remember that OP dash is P dash minus O. So therefore, P dash is OP dash plus O. This is the theory of it. Now let's try to apply this to this question. In this case, O is the center of rotation. And for the first part of the video, the center of rotation is actually 0, 0. So this is simpler than usual because we will only be doing one transformation, which is from OP to OP dash. I'll show you how that works right now. So anyway, let's list the points of our triangle. So we have triangle T. Triangle T has 3 points, A small, B small, C small, for example. So we can just write their coordinates immediately. We have -4 and 1. And then -1 and 1. So this is A, this is B. And then finally, C is -4 and 2. So OA or OP in this case or whatever would simply be P minus O. But O here in this case is 0, 0 because the center is origin. So OP would just be the same as P. So we just copy these down again. No change here. Further down in this video, we will meet questions where the center is not 0, 0. So we will have to do a transformation here. But we're just going one step at a time. So we're dealing with the easier questions first. So here there is no center of rotation. So we don't do anything in the first step. Now in the second step, we're going from OP to OP dash. And we said that in this case, the transformation looks something like this. So AB becomes B negative A. So this will become 1 and 4. This will become 1 and 1. And finally, this will become 2 and 4. And again, for P dash, normally we're supposed to do OP dash plus O. And O again here is 0, 0, so there is nothing to do. So we're just going to write 1, 4 again, 1, 1, and 2, 4. So like I said, for the first couple of questions in the video, you will only be working in stage 2 here. But for stage 1 and stage 3, we're not really doing anything because O is just 0, 0, so there are no transformations to be done. However, in future questions, we will be doing work in stages 1 and 2 and 3. I'm just introducing the general method so that you understand it from the beginning and we apply it all the time. So anyway, the final points here would be 1, 4, 1, 1, and 2, 4. So let's just plot them here. So 1, 4, 1, 1, and 2, 4. These are our 3 points. And we are done with the image of T. So 1, 1, 1, 4, and 2, 4 are the correct answers here. Let's try another one. So rotate triangle T through 90 degrees anti-clockwise about 0, 0. So first of all, let's try to figure out what this means. So anti-clockwise means that AB will be transformed into BA. And anti-clockwise in the original sketch was quarter of a circle here. So it went to quadrant 2. Quadrant 2 has negative x, positive y. So we're just going to write here negative b, comma, a. Now let's draw our table. We have P, OP. P is just a random letter that I'm using as an example. So it doesn't have any significance. So we want to go from P to P dash. Normally, we would have to go through OP and then OP dash and then P dash. This is the normal technique, like I said. But again, here the center is 0, 0. So stage 1 will be nothing. We're not doing any changes. Same as change 3. We're only doing a change in stage 2 where we're applying the anti-clockwise transformation. So let's take the points that we want. We are rotating triangle T. So triangle T has 3 points here. The first point, let's call them A, B, C. So A would be 2 and 2, and I'm going to write it as a vector. B would be 6, 2, and C would be 6, 4. Like I said, in OP, we're supposed to be doing P minus O, but O is 0, 0, so there is no change here. So we still have 2, 2, 6, 2, excuse me. So 2, 2, and 6, 2, and 6, 4. In the second stage or the second process, we are going to flip the two numbers, but we're going to negate the first one. So this becomes negative. Here, again, this becomes negative. And here, this becomes negative. And then for the final stage, because it's 0, 0, we're not doing any change. So we're just going to rewrite them as they are. So these are the final points. We can graph them easily. So we have negative 2 and positive 2. We have negative 2 and positive 6. And we have negative 4 and positive 6. So here is our triangle, our new triangle, T dash. So negative 2, 2, negative 2, 6, and negative 4, 6 are the correct coordinates. Of course, you might be wondering why I'm writing them like vectors. I can just rewrite them easily here as points. Vectors are easier to deal with, and this will become more apparent when we start applying changes in stages 1 and 3. So vectors will be much easier to work with in this case. So that's why I'm just using vectors from the beginning. Anyway, you can easily rewrite these as points. Just take the upper element, put it in the x, take the lower element, put it in the y, and you have your 3 points. We have shape A. We want to rotate it through 180 about 0, 0. So 180 as a rotation, you have AB, and it just becomes negative A, negative B without actually switching the numbers. So we're going to draw our table again. P, P dash, excuse me, P, OP, and then OP dash, and then P dash. I just want you to get used to the way we do it. Even though we don't need this, we can actually just go from P to P dash very quickly. But I just want you to get used to this table so that when we solve the questions that have a different center of rotation, we can apply the same technique. So for P here, we have 4 points that we want to work on. Let's call this A, B, C, and D. Now for A, we have negative 3, 1. This is A. For B, we have negative 1, 1. For C, we have negative 2, 3. And for D, we have negative 3, 3. Like we said in stage 1, because it's supposed to be P minus O, and O is just 0, 0, so we're just going to copy these again. And then from OP to OP dash, we're just going to negate. We're not going to flip. So we just have 3, negative 1, 1, negative 1, 2, negative 3, and 3, negative 3. And then in the final stage, again, because of center 0, center O, we're not doing any changes for now. We're just going to copy them again as they are. And you can write them as points if you want. Make life easier. So this is 3, negative 1, 1, negative 1, 2, negative 3, and 3, negative 3. Now we can graph the points. So 3, negative 1 is going to be located here. 1, negative 1 is here. 2, negative 3 will be here, and 3, negative 3 would be here. And we can just join the points like this. And we are done. This would be A capital dash. Excuse me, let me bring back the text so that we have something to refer to and compare to the marking scheme. So 1, negative 1, 3, negative 1, 3, negative 3, and 2, negative 3 are the correct points. A line joins A to B. The line AB is transformed to the line PQ. Find the coordinates of P and the coordinates of Q after AB is transformed by a rotation through 90 anti-clockwise about the origin. So for anti-clockwise, 90 anti-clockwise, we said you can draw a small sketch to remind yourself. We always start in quadrant 1. So AB becomes BA because it's 90, so we're flipping the letters or the variables. And since it's in quadrant 2, we know that the x is going to be negative. So our result is going to be negative B, comma, A. And we draw the table. Of course, this is again about the origin. So again, we're not going to do anything in the first and the third stages. We're just going to work on the second stage for now. So we have P, OP, OP dash, and P dash. Here we have only only 2 points, A and B. So we're just going to write 1, 3. This is point A, and point B is 5, 8. For the first stage, nothing happens. I'm just going to rewrite them as they are. For the second stage, we are going to flip and negate the x. So -3, 1, and -8, 5. And for the third stage, I'm not going to do anything for now. So -3, 1, and -8, 5 again. So this becomes -3, 1, -8, 5. This would be P, and this would be Q. So -3, 1, and -8, 5 are the correct answers. So now we're going to move on to rotations where the center is not the origin. Draw the image of flag F after a rotation through 180 about point -2, 0. So let's first start with the type of rotation here. The type of rotation is 180. Of course, it doesn't matter whether this is clockwise or anti-clockwise because we said that both of them will yield the same result. So AB becomes -A, -B without switching the variables. And we're going to draw our table again. But here we're going to actually work on the 3 stages for now. So P, OP, OP dash, and P dash. So P here is the points of the flag. Let's just mark the points, the corners of the flag, the interesting points. These are the interesting points here. So A, B, C, and D. But let's just write the coordinates down. So we have A, B, C, and D. A is -6, -1. B is -5, -2. C is -4, -1. And D is -1, -1. Okay, so let me just write the letter D a little bit further down and the letter C as well, so that we know what we're talking about. You can even draw lines like this to separate the points. And now we can begin to work. So to go from P to OP, we said that OP is basically P minus O. O here is the center of rotation, which is -2 and 0. So we can just rewrite this as P minus -2 and 0. So P minus -2 and 0 is the same here as just P plus 2 and 0 because minus -2. So these negatives cancel out, and 0, whether negative or positive, doesn't really matter. So it's just P plus 2, 0. So you're adding 2 to the x and you're keeping the y as it is. So this would be here -6, -4, and -1. We're just adding 2 to the x. So -3, -2. And C, this is supposed to be -4 here. So if you add 2 to that, it becomes -2. And this is the same, -1. And finally, here we have 1 and -1. And the type of rotation here is 180. So we're not flipping anything, but we're just removing the signs. We're switching the signs. So this becomes 4 and 1, 3 and 2, 2 and 1, and finally -1 and +1. And then for the last stage to get P dash, now this is stage 3. So we said that OP dash is P dash minus O. So P dash is basically OP dash plus O. So now we're just going to add the O, which is -2 and 0. So we're just adding here -2 and 0. So we're reducing each x by 2, and we're keeping the y as it is. So the final vector will be 2, 1, 1, 2. We're just minusing 2 from the x, or like the upper element of the vector. 0, 1, and -3 and 1. These can be written as points, of course. So these are the corresponding points, and we can plot them onto the graph quite easily. So we have 2, 1, 1, 2, 0, 1, and -3, 1. And this is how the flag is going to look like. This is f dash. So here they didn't really specify what the answer is, but we can make sense of it. It looks correct. It is a 180 degree about -2, 0. So this is the center of rotation. This looks like a 180 degree rotation about the center. So the answer looks like it's correct. Here we're asked to rotate shape T about the point 5,3 through 180 degrees. So again, we're going to construct the table. We have P, OP, OP dash, and P dash. Now, the points here are labeled. So that's just A, B, C, and D. So A would be 2, 1. And B would be 5, 1. And C would be 5, 3. And D would be 4, 3. And we can begin to carry out our transformations. So the first thing we want to do is get OP, and OP is going to be P minus O, which here would be P minus 5, 3, the center of rotation. So the transformation here is going to be minus 5 and 3. So 2 minus 5, for example, would give us -3. 1 minus 3 would give us -2. We're subtracting 5, 3 from each vector. So here this would be 0, -2. And again, this here would be 0 and 0. 5, 3 minus 5, 3, of course, would be 0, 0. And the last one is 4, 3 minus 5, 3. So that's just -1 and 0. And the type of transformation here is 180 degree. I forgot to specify that. So 180 degrees means AB becomes -A, -B without flipping the coordinates. So this would become here 3, 2, 0, 2, 0, 0, and finally 1, 0. Our last step is going to be to get P dash. And P dash, like we said before, is simply, so OP dash is P dash minus O. So P dash would be OP dash plus O. So we're just adding the center of rotation again. So we're just adding here 5, 3 to get our last vector. So add 5s to the x's. You can even work the x's alone and then work the y's alone. That's easier for you. You just add 5 to the top element of each vector. So we have 8, 5, 5, and 6. And then for the y's, you just add 3. So you have here 5, 5, 3, and 3. And these would be the final points. 8, 5, 5, 5, 5, 3, and 6, 3. We can plot them now onto the graph. So 8, 5 would be somewhere here. This is 8, 5. And then 5, 5 would be here. 5, 3 would be here. And 6, 3 would be here. So your shape is going to end up looking something like this. This is T dash. This is a 180-degree rotation about the point 5, 3. Let's check the marking scheme. So the image is at 5, 3, 6, 3, 8, 5, and 5, 5, as we did. We have the same points, and this tells us that our answer is correct. So for the remainder of this video, we shall be given a drawing and asked to describe what the rotation is. This is slightly harder than what we did before. So describe fully the single transformation that maps triangle A onto triangle B. So first of all, you need to figure out whether it's a translation or a reflection or a rotation or an enlargement. So in this case, they have the same size, so it's not an enlargement. It's not a translation because the orientation of the shape is different. The A is rotated to B. It looks very clear here that this is a rotation. So the first keyword here is to say this is a rotation. And then we need to specify the type of rotation and the center of rotation. So the type is quite easy. To go from A to B, logically, you can think of this as being rotated 90 degrees anti-clockwise, so that it becomes looking like this. So if you rotate it 90-degree anti-clockwise, it will look like B. So the next piece of information we want to say is that this is 90 degrees anti-clockwise. And then we want to get the center, and this is the hard part, because this is what requires doing the table. So we don't know what the center is. So the center here is going to be something like XY, for example. And we want to figure out X and Y. Now, we're going to do the table again. So we have P, OP, OP dash, and then P dash. But we only need one point. We don't need to create that many points. So we just need, let's take this point, for example, here. So this point is -3 and -3. And the corresponding point on the new shape, this is the 90-degree angle. So we can see here that the new point becomes -5 and 1. So that's what we want to reach here, -5 and 1. So to go from P to OP, we say we do P minus O. So we're doing minus X and minus Y, or like minus vector XY. This is the same as saying minus vector XY. So we just subtract the X from the numerator and the Y from the denominator. We get -3 minus X and -3 minus Y. This is our new vector here. Now to go from OP to OP dash, we need to specify what happens here, what kind of rotation here. So this is 90 degrees anti-clockwise. And in anti-clockwise, let's draw a small sketch to remind ourselves. We have a point here that goes here. So AB becomes BA. We flip because this is 90 degrees. And In this quadrant, the x is negative, so we write negative BA. So we're going to flip. We're going to get negative 3 minus y and negative 3 minus x. But we're going to negate the top one because it becomes negative b instead of b. So these are actually going to be positive, not negative. And then in the final stage here, we said that P dash equals OP dash plus O. So we're going to add X and Y. So we're just going to add X here, and we're going to add Y here. It looks complicated, but it really isn't. We're almost done. So 3 plus Y plus X equals negative 5, and negative 3 minus X plus Y equals 1. We have two equations in X and Y. All we have to do now is just add these equations together, and you'll see that it simplifies itself. So 3 plus negative 3 is 0. And then x and negative x added together give us 0 as well. So these would cancel out, and these would cancel out. And we would be left with 2y equals negative 5 plus 1, which is negative 4. So therefore, y equals negative 2. And then we go to the first equation, for example, and we rewrite it as 3 plus negative 2 plus x equals negative 5. So 1 plus x equals negative 5. So therefore, x equals negative 6. So now we have a center of rotation. The x is negative 6, and the y is negative 2. So let's check the marking scheme. So it's a rotation 90 anti-clockwise with a center of negative 6 and negative 2. Describe fully the single transformation that maps triangle A onto triangle B. So again, this obviously looks like a rotation. I'm going to write rotation here. And from A to B, it looks like you're rotating A in the anti-clockwise direction. So it's 90 anti-clockwise. So we're going to write here 90 anti-clockwise. And then we want to get the center, and this is what requires the table. So just let's take this point here, and we should know that this corresponds to this point there. Now let's do the table. We have P, and then OP, and then OP dash, and then P dash. So P here is our initial point, which is negative 2 and 2. We write it as a vector here. And P dash is the final point, which is negative 2 and negative 4. So to go to OP, we're going to do minus x minus y. This is our vector here, because we're subtracting O, which is xy, which is unknown. Remember, the center here is just unknown. So we're just calling it xy for now. So we're going to subtract x and then subtract y. So we get negative 2 minus x and 2 minus y. This is our new vector. Now, this is 90 degrees anti-clockwise. So from a simple sketch, you should know that we go from AB to BA, but the B is negative because it's quadrant 2. So we have negative BA. So let's first flip them. So this is 2 minus y, and this is minus 2 minus x. But it's negative b, so we're going to add the negative here and the positive here. We're just going to switch the signs of the upper element. And then finally, we're adding O, so we're adding xy to our vector. So we have here plus x, we have here plus y, and we have two equations. So negative 2 plus y plus x equals negative 2. And negative 2 minus x plus y equals negative 4. Next, the easiest way to solve these two equations is to just add them up together. So negative 2 plus negative 2 is negative 4. and then y plus y, this is 2y, and x minus x, because it's plus negative x, so this is plus 0, and all of this equals negative 6. So negative 4 plus 2y equals negative 6. You can take the negative 4 to the other side. 2y equals negative 6 plus 4. 2y equals negative 2. So y equals negative 1. And that's it for the y. We can plug it here. So we get negative 3 plus x equals negative 2. So x equals negative 2 plus 3, which is positive 1. So the x is 1 and the y is negative 1. So we just add center 1, negative 1. So this is rotation, 90 anti-clockwise, center 1 and negative 1. Describe fully the single transformation that maps triangle A onto triangle B. So again, this is a rotation, obviously. And here you can see that A needs to be rotated clockwise by 90 degrees. So this is 90-degree clockwise rotation. And we want to get the center, of course. So I'm going to take a point, so 0, 1 to 6, 3. We have here 0, 1. This is P. We want to get OP, and then OP dash, and then P dash. We draw the table. So first we're going to subtract x, y. You can either do minus the whole vector, or you just understand that you're doing minus x here and minus y here. So we get negative x and 1 minus y. And of course, the final point, which I forgot to write, is the corresponding point in B. So this point here becomes this point. So this is 6 and 3. We have to write the result here. So this is 6, 3. Now, the rotation here is from OP to OP dash, and it's a 90-degree clockwise rotation. So this point would go clockwise by 90 degrees. So AB becomes BA, because 90 means we flip the letters. And the x here is positive, but the y is negative, so it's B negative A. So here we're going to negate the y, or the bottom element of the new vector. So first, let's flip the vector. So we have 1 minus y here. We have negative x here. And then let's negate the bottom element. So this becomes positive x. Finally, let's add our center. So our center is x and y. So we have here plus x plus y. And we can form two equations. So 1 minus y plus x equals 6. And x plus y equals 3. Finally, we add these up together. So we have 1 plus nothing, which is 1. And then these will cancel out. So 1 plus 2x equals 9. So 2x equals 8, and x equals 4. If we put x here as 4, of course, we can get 4 plus y equals 3. So you take the 4 to the other side. Y becomes negative 1. And we can say that the center is just 4 and negative 1. So it's a rotation 90-degree clockwise, center 4, negative 1. Describe fully the single transformation that maps triangle A onto triangle B. Like we said before, you have a rotation, and it's 90 degrees clockwise. How did I know that? You just try to visualize it. You want A to go to B, so it looks like this triangle here needs to look something like this. So this point is sort of moving in the clockwise direction in order to become this point here. So this is a 90-degree clockwise rotation, and then we need to take an initial point and a final point. So let's just take this point here again. So this is negative 4, 4. And this ends up being here, which is 4, 4. So let's do our table. P, OP, OP dash, and P dash. So our point is negative 4, 4. We subtract our center, xy. So negative 4 minus x, and 4 minus y. This is our new vector. The type of rotation here is 90 clockwise. So we're going from here to there. This is AB. This becomes BA. And here again, the y is negative. So we flip them. So this becomes 4 minus y, then negative 4 minus x. And the new y becomes negative. So we negate these signs here. So this becomes 4 plus x. Finally, to go from OP dash to P dash, we have to add our center. So plus xy. So we have here plus x, we have here plus y. And this leads us to the final point, which we already know is 4, 4. So we have an equation here to write. 4 minus y plus x equals 4. 4 plus x plus y equals 4. We add them up. 4 plus 4 is 8. Negative y plus y, they cancel out. X plus x would be 2x. And this here would be 8. So 8 plus 2x equals 8. So 2x equals 0. So x equals 0. If you put x as 0 here, you get 4 plus y equals 4. So y is 0 as well. So therefore, the center here is 0, 0. So it's a rotation 90-degree clockwise, center origin or center 0, 0. Describe fully the single transformation that maps triangle A onto triangle D. So again, this would be a 90-degree clockwise rotation. And we want to get the center. So we take a point. So this point here becomes this point. And we draw our table, P, OP, OP dash, P dash. So P here is 4, 1. And P dash is 3, negative 4. First thing is we subtract the center. So minus x minus y. So we have 4 minus x, 1 minus y. And then to get OP dash, we remember this is 90 clockwise. So AB becomes BA and the y is negative. So B negative A. The y is negative because this is quadrant 4 and the y is negative here. So we flip them first. We have 1 minus y and 4 minus x. And then we want to negate the y. So this becomes negative and this becomes positive. Finally, we add our center. So this here becomes plus x. And this here becomes plus y. So 1 minus y plus x equals 3. Minus 4 plus x plus y equals minus 4. And you add the two equations together. 1 minus 4 gives us negative 3. And the y's will cancel out. And the x's here will be 2x. 3 minus 4 is negative 1. You take the negative 3 to the other side. So 2x equals negative 1 plus 3. So 2x equals 2 and x equals 1. Now we put the x as 1 in either equation. So let's put 1 here. We get 1 minus y plus 1 equals 3. So 2 minus y equals 3. Negative y equals 1. Y equals negative 1. So I took the 2 here with a negative, of course. 3 minus 2 gave me 1. So now we know that the y is -1, and we can write that the center here is 1 and -1. So we have 90 degrees clockwise, and the center is 1 and -1. Describe fully the single transformation that maps triangle A onto triangle B. So again, we need to specify first what type of rotation this is. So this is a clockwise rotation. So this is a 90-degree clockwise rotation. You have to write rotation and just write 90-degree clockwise. There is one mark for this and one mark for that. And the third mark is for the center. This one is the one that requires some work. We have P, OP, OP dash, and P dash. We will take one point and the corresponding point. So our point here would be 5, 6. And the corresponding point would be 7, -4. To get OP, we subtract here x and here y. We have 5 minus x, 6 minus y. To get OP dash, we need to figure out what 90-degree clockwise means. So we're going from here to here. So AB becomes BA, and here the y is the one that is negative. So we get 6 minus y and 5 minus x, and then we negate the y, so it becomes, we negate the j, or like the bottom element, so it becomes -5 plus x. And then finally, we add the center, which is xy. So here we have plus x, and here we have plus y. So 6 minus y plus x equals 7. -5 plus x plus y equals -4. And then you add the two equations up together. 6 minus 5 is 1. The y's cancel out, so 1 plus 2x equals 3. So 2x equals 2. And therefore, x equals 1. Now we plug x as 1 here, for example. You get, you get 6 minus y plus 1 equals 7. So 7 minus y equals 7. So the y here, of course, would be 0. And therefore, the center is 1, 0. So 90-degree clockwise rotation, center 1, 0. Here we have triangle A and triangle C. Of course, this here is a 90-degree clockwise rotation again. And we want to get the center. So we have P, OP, OP dash, and P dash. So P here is this point maybe. Here, this is P dash. So 1, 2, and then 2, -1. So this here would be 1, 2. And the final point here would be 2, -1. OP would be 1 minus x, 2 minus y. To get OP dash, we want to figure out the 90-degree clockwise. So again, this goes from here to here. So A comma B becomes B comma A, and the y is negative here, so it's B comma -A. So here I'm going to flip the vector as well. I get 2 minus y, 1 minus x, and then I change the sign of the lower element. So this becomes -1 plus x. Finally, to go from here to here, I'm going to add x for the first one and y for the second one. just in case you forgot why we're doing that, we are adding because OP dash equals P dash minus O, and O here is the unknown center of rotation. So P dash would be OP dash plus O. So we're just adding this center of rotation to our OP dash. We're adding X to the first and Y to the second. So this gives us two equations, 2 minus Y plus X equals 2, and -1 plus X plus Y equals -1. We add them up. So we get 1, and then the Y's cancel out. So 1 plus 2X equals 2 plus -1, which is +1. So X here is 0. And if we put 0 here, 2 plus 0 equals 2. So the Y will be 0 as well. So the center here is the origin. And that's it for this question here. 90 degrees center origin, and of course it's a rotation. So in this question, we are asked to describe fully the single transformation that maps flag A onto flag D. Now, a flag looks a bit different than what we're used to, but the concept is still the same. First, we need to figure out the type of rotation here. And this obviously looks like a 90-degree anti-clockwise rotation. So 90-degree anti-clockwise rotation. We want to get the center. So in order to get the center, we need our table, P, OP, OP dash, and P dash. Let's take a random point on the first flag, flag A. Let's take, for example, this point here. And then let's take the corresponding point on flag D. So for flag A, we have -8 and -8. For flag D, we have 7 and -8. So to get OP, as usual, we will subtract X from the first and subtract Y from the second. To get OP dash, we need to figure out what type of rotation this is. This is 90 degrees anti-clockwise. So from here to here, AB becomes -B, comma A. So we're going to flip them both and then negate the upper element. So this becomes -8 minus Y, -8 minus X as a vector. And we will negate the upper element. So this becomes +8 plus Y. Finally, we add X here. We add Y here because we're adding the center of the rotation here, which we don't know, which is X and Y. So we have 8 plus Y plus X equals 7. We have -8 minus X plus Y equals -8. So I just made a very small mistake that I'm just going to correct very quickly. So the coordinates of the initial point here were actually 8 and -7, not, -8 and -7, not -8 and -8. So this here actually becomes -7, and this here as well becomes -7. And when we flip, this here is going to be 7. So this is a small mistake here that will affect the result, unfortunately. So it's good that we caught the mistake before continuing. So this is actually a 7, not an 8. And now we're going to just add the numbers. So 7 minus 8 is -1. -X and X just cancel out. So I get 0. Y and Y gives us 2Y. 7 plus -8 again is -1. So -1 plus 2Y equals -1. So 2Y equals 0. So Y equals 0. If we plug 0 here, we get 7 plus 0 plus X equals 7. So X is also 0, of course. And therefore, we just write here center 0, 0. So this is a 90-degree anti-clockwise rotation around the origin or center 0, 0. And this brings us to the end of our video. I hope this has been beneficial. Thank you for watching.